Alright, got a different video today, doing a partial disassembly and inspection of my RS19 LiTech battery packs. And the reason I'm taking them apart is because I had a spill with my wheel and it got partially submerged, and I noticed that on the heat shrink there was some damage on one, some rubbing that occurred. I'll put the screenshot up. And on this one there was a little bit of let's see if I can get this on the camera, a little bit of pull away for the silicone glue holding it together. And so both packs really had an ingress where water could get in, so that's never a good thing with these types of batteries. And I'm just going to take this opportunity to, I guess, just verify some of the claims that were made with these batteries from eWheels and LiTech, and take a look at the quality of the build and the features that were claimed, and generally give my thoughts on this. So without further ado, I've already disassembled one. This one here I'll take apart on camera partially, but this is only going to be a very partial disassembly. I'm not going to take apart all the cells and cell holders. So that being said, I won't be able to check everything, but it should be alright for what I can check. So you notice right off the bat, this pack, I don't know if you can get this on camera here, but this pack was produced July 12th, 2021. And I got my wheel shortly after that. And I put about 2,000 kilometers, a little less than 2,000 kilometers on these packs. So, and you'll notice right off the bat too that there's supposed to be a buzzer here. Well, I got rid of that. Not really my choice, but when I was disassembling the wheel before, the pack isn't really held in there perfectly, and I leaned it over and the battery pack fell out and ripped this off. And I was like, oh well, no big deal. So communicating with the eWheels, they've never had any fires before with these LiTech packs, and I wasn't too concerned with a high torque wheel generating too much heat. So to me, it's just a feature I didn't really need. It's nice to have the buzzer for the overheat condition, but I didn't need it. So anyway, first things first, you're gonna want some kind of tool to take this apart, some kind of non-conductive tool. You don't want to accidentally short any of these batteries. So I'm using some kind of plastic wedge that should be able to break in between the heat shrink. So let's try and get this started. You know what? Let's start with the ends. Kind of pull away at this. I think I already started with this one before I start rolling the camera. These end plates here, they're that weird kind of brittle plastic, so you can bend them, but what ends up happening is they crack, and that leads to another point of ingress. So I think what I'm going to do when I reassemble it is use duct tape over top of it, and then silicone, and then heat shrink on top of that, and then silicone to the heat shrink, and that should get rid of this kind of deficient cover here. Anyway, so I want to be careful around the wires. Kind of press them down at the same time. All right, let's have a look at that. So I like what I see. I don't see dirt. There's a little bit of rubbing going on. but I don't see what I would expect to see if it wasn't sealed, which was like dirty water and all that kind of stuff I had to clean my wheel out with, which is a really good sign, but it's been working for months anyways, so I wasn't that concerned about, you know, a short, because it would already happened by now. But anyway, it's a good thing to see the inside of all the cells. I don't see any dirt, so that's great. No water residue. So, and okay, so the back, this is where the BMS is. Here you can see the temperature probes on some of the MOSFETs. I'm not going to be removing this, unfortunately. Like, if it's not broke, or if it's working, it ain't broke. Don't go too far. That's kind of my philosophy here. So I'm going to leave this on, which would have made for a better video to really get into that, but I'm not going to do that. So anyway, that's the disassembly. I'm gonna, with this one, with both of them, you see how it's cracked now. Let's see if I can reposition this. Let me get the light on it. Yeah, it's cracking through here. So what I'm gonna do is put duct tape all over that, and that's gonna help me seal it when I go to reassemble. But yeah, I like what I see. You got the 50E Samsung. You're not gonna be able to tell if they're actually 50Es, like truly tell, unless you test them to a known genuine cell, probably. And they also have stamps on the cases that you can verify numbers and stuff like that. But I'm not gonna get into the wrapping, because anyone can put any kind of wrapping on these. But I'm not too concerned about that, the genuine cell situation. It would be nice to dig into it further, but I'm not going to do that with this video. So I already have the other battery with this removed. So we're going to look at that right now. Put this aside. Here it is. So these, if you just carefully pry these up, you get the exposed connections. And you can see on both sides, basically the same thing. Here you have your parallel balance leads go into the BMS. So I think to start, I'm going to start with the dimensions that was claimed by eWheels, and I'll put the screenshot on the screen. But basically they show the goad and a LiTech dimensions for their strips, what they claim is nickel strips. And so here they say, so I'm going to use, let's see, I don't know if the camera's going to pick this up. Yeah, we got 0, I'm in millimeters, 0.01, whatever, that's close enough. Well, I'll just zero it out. And here, so they're claiming 5 millimeter dimensions for LiTech. I got 2.5. So already that's not to the spec that they claimed. Not that I'm that concerned about that. There's not a lot of current that goes through these balance leads. In fact, it's very little at when it's top balancing at the end of its charge cycle. So yeah, it's not that big a deal. But that's not what they said on their spec, so that is interesting. So something else too is the width. This is the important one. So we got about, let's see, 9.5. See that? Let's see, yeah, 9.5 to whatever. 9.5 millimeters, they claim, let's see, 10, it looks like. Good enough, that's in the ballpark. That's totally fine. Now one thing I really wanted to check was whether or not these strips, and by the way, if you ever get your battery apart like this, be really careful, bridging these connections. Make sure you know what you're doing. You're not gonna put something across them that could start a fire. easily. Very important to keep that in mind. But anyway, yeah, especially since I have those off and they're exposed. So I'm going to be very careful with this metal implement and not laying it across. Anyway, what was I saying? Oh yeah, so one of the claims from eWheels for these LiTech packs was that Bigode was using nickel-plated steel, and the LiTech packs were going to be pure nickel. It's difficult to test, especially on camera, because the nickel strips you'll get are somewhat magnetic, and then the nickel-plated steel is more magnetic. So one way to kind of, so I have some pack building experience, and I've, you know, placed some orders from AliExpress, and I've gone through and gotten, you know, nickel-plated steel when I wanted nickel before. So I have a general sense of what the difference is, even just looking at it. And to me, right off the bat, these look like nickel-plated steel, which is what Bigode was using. So that's a big disappointment to me. You know, steel has a conductivity that's, what is it like? So if you look at copper's conductivity and you say it's 1, well, nickel is 4 times less conductive than copper, and then steel is 10 times less conductive than copper. So you get a little bit of an inefficiency for connections when you get away from copper, particularly as far away from copper as steel in terms of electroconductivity. So these look like steel, and I was trying to figure out how I'm going to show on camera how I could prove to some degree that it is steel. Well, I do have these, and I should be really careful around, again, open circuits there. I do have these 2 plates. These are for pack builders. One of them is a nickel strip, and one of them is nickel-plated steel. And I don't know if you can see on camera, but anyway, one of the luster of one, you know, is a little duller, and the luster of this one is a little shinier. And they also feel a little different. They have a little different. So here's one thing: the sound. Listen to that, and the sound, totally different, right? So you can tell right away, even though these are, you know, the same thickness, same general dimensions, they make quite a big difference in sound just dropping them. So that's interesting. That's not what I'm going to test, but it's just an interesting difference. So the look, the sound, and let me just show you, you know, just for demonstration purposes, the thickness here. So that's about 0.15. If I press it in, it's supposed to be 0.15 millimeters. Yes, the 0.15 millimeter thickness for that one, 0.15 for this one. I don't know if I got that in camera, but they're the same. So what I figured is, I have this little magnet, rare earth magnet, and I'm going to do a pull test. And let me set up the camera a little better so I can try and show this. Alright, so here's a little impromptu pull test that I figured I'd show on camera. Get the difference, to sort of prove that there's a difference in the magnetism between these two metal strips. So I'm going to do the nickel-plated steel first, and I'll hold it right here, and then I'm going to draw it up very slowly. And look at how much the metal bends before it's going to let go. Right about there. I'll do the same thing with the nickel-plated, or the nickel, pure nickel, and it's gonna, oh, it barely pulls at all to right there, versus, see, it wants to grab right away, right up there. So that's kind of the difference. You can tell it's got a lot stronger pull to it. All right, so now for the true test. So I have a general feel of how that felt for those two different metals, and with my pack building experience and all that, I know what's pure nickel and what's steel. It's a nickel plated steel. So I'm gonna put it up to what this these strips. I get a good amount of draw from this magnetism. Pretty magnetic versus this one's the nickel. Barely anything. If I just hold it the way it's held on here, if I hold this strip, get a little bit of light here. If I hold it right here, it's the way the strip is held to the batteries. There's like barely any draw from it. Same thing here. There's a significantly noticeable draw. And that's not surprising me at all, because again, this looks like nickel plated steel, not pure nickel. And even this doesn't even have as much. To me, it doesn't feel like this is the nickel plated steel. This doesn't feel like it has as much a draw as this. Now, these batteries are steel cased, so you could say, well, you're just getting confused because the magnet is being attracted to the steel case. Well, that you could have a point, but if I put it in between, I don't feel any magnetism here, right? And here's in between the cells. It's all coming from the strip. So the look, the luster, the fact that this actually looks thinner. I can't get the calipers on you know, that area there to figure out how thin it is, but it looks thinner than this. This is 0.15 millimeters. This is probably 0.1. So that is for me, it's confirmation enough that this isn't what they said it was. And I can bring it up here. Interconnect nickel strips of pure nickel. I'll put the screenshot on. But yeah, that's disappointing. That's a little disappointing. So there's that test. Now, one thing that's interesting too to note while we're looking at the top of this is the cell holder. Now, none of this metal is sticking up, and that's great. You don't want any of the metal getting caught or getting hung up as that battery shifting around as you're using your wheel. Even these parallel connections, they're recessed, so that's good. As far as the cell holder itself, it's like being improved over the Gode's original design. I can't tell one way or the other if it's an improvement or not, but none of it looks damaged. I do like, you know, this separator here, this yellow separator. Everything is solid. I don't see anything wrong with the holders. It looks good. The assembly looks good. These batteries are packed in tight. It's consistent. You know, even though the cell interconnects are, in my opinion, and from what I've shown, nickel plated steel, it's still well put together. And not just that, if you look at the welds here, they all have marks. That's got to be their QC check. So you don't want any of these to come apart and, you know, to have instead of a 2P parallel group, you have a 1P, and then, well, you're running into problems real quick when you go to charge or discharge. So you can see that they have, you know, checked consistently all the spot welds. That's good to see. And even look at this. Look at how this plate back here that's kind of sandwiching the BMS against it. It's so thin. everything is so compact and tight, there really isn't much room to mess around with the design at all. So it's, you know, it's a pretty good design. Obviously, it holds up for most people as long as you're using the correct cells that aren't overdrawing what they can deliver. And the 50Es, at least in my personal experience, that's all I'm going to speak about, at least in the high torque version of the wheel, do a good job. They have been doing a good job. So I like what I see for construction, the holders, but yeah, it was disappointing to see that these are nickel plated steel, not nickel. All right, what else? Oh, so going back here, looking at the back here, well, I'm not going to remove this cover. These two temperature sensors, if I wanted to test them, I would just pull them away, shoot them with a heat gun, and then theoretically, after 75C, I think it would cut power to the mains. So that would be interesting to test. I'm not going to do it in this video, probably never. But if anyone else wants to go further with this type of disassembly, by all means. Here, these will be covered again. Those came off really nicely. I'll just show you one on screen. See, the glue is still on it, so that I can go back on pretty easily. Oh, so there was one more thing I wanted to check while I had this all apart, was just checking the difference between the parallel groups. So I said earlier this was about 2,000 kilometers, a little less than that, on these packs, and I was really interested to see how well the top balancing is going, if it's doing its job or not. So the only way to do that with the things I have exposed is to look at two parallel groups, or no, two groups in series, the difference between the two. So let's just start with that. So yeah, so for the first group, I got 7.66 volts. Second, 7.66, same thing. That's 11 groups. That's what we can get with these connections. The last just ties in, like, I think 22p together, something like that. Yeah, 84.3 plus 7.6. That's going to be nominal voltage of, let's see, 90 something. Yeah, 91.9. So that all checks out. I like that. These are all really consistent voltages across the parallel group. So there you go. It's been doing its job. That's great. I can't complain with that, even though top balancing is not the greatest at all method. I would love to see in real time on my phone or whatever app what each of the parallel groups voltages are, so I could, you know, really be sure as I'm using the wheel, and I don't have to disassemble everything to check if the balancer is doing its job. That would be great, but it's obviously not happening with the design currently with these batteries. So that being said, to have them with a range of 0.03 volts, that's really good. No complaints there. Balancer's doing its job. Good to see. So that was the last thing I wanted to check. I'm going to do the same thing off camera with my other pack. If there's a problem, I'll let you know. I'll just splice in another bit, but that's probably going to be fine too, but I'll double check off camera. So you can just assume that that one's good too. So in summary, these LiTech packs, from what I put them through, you know, with my trail riding and numerous crashes and wrecks, and even submerging both of them partially for, I think, 10-15 seconds before I was able to pull them out of the swamp. And then for them to look this clean, even with probably vibrational damage or whatever on the side and some rubbing. Water didn't get in, so that's really good. Construction looks really good, no complaints. I don't see any damage from everything I've been doing. So, and balancing also, that's great. The one downside is I'm not 100%, but I'm pretty damn sure these are nickel-plated steel. Even the edges, with my pack building experience, the edges remind me of nickel-plated steel, working with it. So that is unfortunate to see, because it's such a small piece of the build in terms of cost savings, so it's like, why? That being said, I mean, it still works. There's no heat damage either from, the additional resistance of having, in my opinion, subpar cell interconnects. So that being said, I mean, no one's going to notice this at all. It is a minor point, but it was claimed to be one thing, and in my opinion, in my assessment, which is again my opinion, it does not seem to be pure nickel as claimed. So, but everything else I can't complain about. It's working, it's been working, and it's still going to work in the future. I'm going to seal everything back up. I'll probably put some screenshots. I'm not going to narrate. The video is long enough. I hope you got something from this. Probably still going to trust the LiTech packs over Begode. Oh yeah, if you're interested, I got a affiliate code with eWheels. I don't know if they're going to be happy with this video, but either way, I think it's interesting, and all in all, still a good improvement over let's just say the older 900 watt hour packs. Let's just put it that way. All right, guys, that's it for me.